The roots of this quadratic equation are alpha and beta. Find a quadratic equation with roots 2 alpha and 2 beta. The first thing I'm going to do is I'm going to write down the sum and the product of these two things. Alpha plus beta is equal to 4 over 3, and alpha times beta is equal to minus 2 over 3. And I'm going to use those a few times. Now, what I know is if a quadratic equation has roots 2 alpha and 2 beta, then the sum of those two roots has to be equal to minus b over a for my new quadratic. Now, this factorizes to 2 lots of alpha plus beta. And alpha plus beta we know is 4/3. So this is 8/3 equals minus b over a. We also know that the product of these two roots, 2 alpha times 2 beta, has to be equal to c over a. But this is equal to 4 lots of alpha beta. Alpha beta is minus 2/3, so this is minus 8/3 is equal to c over a. From here, we can read off the values of a, b, and c for our new quadratic. That means a has to be equal to 3. Well, actually, it's minus 3, because in both of these the sign has changed. So a is equal to minus 3, b is equal to 8, and c is equal to 8. That means our quadratic equation is going to be minus 3x squared plus 8x plus 8 is equal to 0. Now, this quadratic equation will have roots that are equal to 2 alpha and 2 beta, whatever alpha and beta are. Now let's do a similar thing for this next one. This time it's 1 over alpha and 1 over beta. So the roots are 1 over alpha and 1 over beta, so we know that 1 over alpha plus 1 over beta has to be equal to minus b over a for our new quadratic. Simplifying this is alpha plus beta over alpha beta is equal to minus b over a. And alpha plus beta we saw was 4/3, and alpha beta is minus 2/3. Simplifying this down, we get minus 2 is equal to minus b over a. I'm going to write it as 2 over 1 because that's slightly easier to see what's going on. We also know that 1 over alpha times by 1 over beta is equal to c over a, which means 1 over alpha beta is equal to c over a. Alpha beta is minus 2/3, so this is going to be minus 3 over 2 is equal to c over a. It's not as immediately obvious here because in this case we're suggesting a is 2 and in this case we're suggesting a is 1. But that's a fairly easy fix. If instead of writing this as minus 2 over 1, we write it as minus 4 over 2, now a is the same in both equations, so a must be equal to 2. We've already got the minus, so b must be equal to 4, and c must be equal to minus 3. So if a is equal to 2, that works. If b is equal to 4, that works. And if c is equal to minus 3, that works. So an equation with these roots would be 2x squared plus 4x minus 3 equals 0. Finally, similar idea, but the roots this time are alpha squared and beta squared. So alpha squared plus beta squared is equal to minus b over a. Using what we saw in a previous example, this is the same as alpha plus beta squared minus 2 alpha betas. Alpha plus beta is 4/3, so this is 4/3 squared minus 2 lots of minus 2/3. Simplifying, we get 16/9 plus 4/3, which I'm going to change to 12/9, which means we have 28/9 is equal to minus b/a. Now using the product, alpha squared times beta squared is equal to c/a for any quadratic. This is alpha beta squared. Alpha beta is minus 2/3, which means we have 4/9 is equal to c/a. This will work if a is equal to 9, it's the denominator on both of them. B then needs to be minus 28, and c needs to be equal to 4. So the quadratic equation would be 9x squared minus 28x plus 4 is equal to 0. So these examples show how, without knowing the roots, we can find a new equation that has related roots using the product and sum of the roots formulae for quadratic equations.